very quickly, I want to explain. Okay, listen. Very quickly, I want to explain how to solve this question. This is on number base. 125 base x equal to 20 base 10. Where to find x? The step is to convert everything to base 10. Convert the left side to base 10. So that will be 1 times x raised to power 2 plus 2 times x raised to power 1 plus 5 times x raised to power 0, then equal to 20, which is already in base 10, but we're just taking this one to base 10. So what we have to do now, or how did I get the powers here? When I picked the first digit 1, I simply counted how many numbers remain, and that's 2. So that's why there's a 2 at the top here. And when I pick this 2, it's here. I multiply by the base, which is also x. Then it remains one digit. That's why there's 1 here. And when I pick the 5, it's here. I multiply it by x, and it's here. Then there is no digit remaining. That is a 0. So the first 1 times x raised to power 2 digits that remain because of the place values. Then the second number, which is 2, times x, then raised to power 1 digit that remain. And the third number, which is 5, times the base again, then remains nothing. So 1 times x squared is x squared. 2 times x raised to power 1 is 2x. And 5 times x raised to power 0. X raised to power 0 is 1. So 5 times 1 is 5 equal to 20. So here we can say x squared plus 2x plus 5 minus 20 equal to 0. Then we have x squared plus 2x. 5 minus 20 is negative 15 equal to 0. So this is a quadratic equation for us to solve. Look for two numbers you multiply to give you negative 15, and you add them to give you positive 2. What are those two numbers? That is 5 and minus 3. 5 times 3, or 5 times negative 3 is negative 15, and 5 plus negative 3 is 2, because that is 5 minus 2. So we have x squared plus 5x minus 3x minus 15 equal to 0. So those two, I use them to replace this middle term. So if we say 5x minus 3x, that is still 2x. So we have not changed this equation from this one. Now we have to factorize. X is common to this and this. I'll remove the x and put a bracket. Then I have only one x left and a 5 when I factorize. Then negative 3 is common to this and this. So I put negative 3 outside. Then I have x plus 15. X plus 5 rather. Such that when I open the bracket back, I can multiply this to get this. Then I can multiply this to get this. So with that, we have two sides on the left, this side and this side. So x plus 5 is common to the two sides. We'll pick it for the next step. Divide the bit. So we have x plus 5. Then once I pick x plus 5 here, it remains x outside. So I pick that x uh, here. Then once I remove this, it remains minus 3. So I pick minus 3, then equal to 0. So when you multiply two numbers to give you 0, one of them must be 0. So that means x plus 5 equals 0, or x minus 3 equals 0. So they could both be 0, and one of them could be 0 in order to get a product of 0. So what are we doing here? We can say x equal negative 5 here, or x equal positive 3 here, which is just 3. But because we're looking for a base is what we're looking
So
for,
I'm
and
done.
base cannot be negative. Okay, hold on, let me enter into this too. Okay, you're done with that, right?
Yeah.
Okay. What's your answer?
Answer is 10.
10. Okay, we're going to look at it
Yeah.
together shortly now. Or you want to send it?
I'm already sending it.
Oh, okay, I'll bring it up. Wait. So, x cannot be negative. So, x can be positive. So x equal to 3. So I'm bringing up your work now. I think I will have to rotate this to the right, not to the side, but to rotate right. Okay, so let's see. I think your work should be correct, but let's just see it together. So you to convert everything to base 5 for the second question. So 5 times x raised to power 1 plus 5 times x raised to power 0. Then the plus at the middle, which is this one. Then 5 times x raised to power 1 again plus 2 times x raised to power 0 equal to 77, which is already in base 10. Can you hear me?
Yes.
Good. So this is 5 times x, which is 5x. And anything raised by 0 is 1, so this is 5. Then this is also 5x. Anything raised by 0 is 1. This is so 2 times 1, that is 2, equal to 77. So we have 10x. 10x, because of 5x plus 5x, then we have 7 plus 77. So 10x equal to 77 minus 7. 10x equal to 70. Okay,
Yeah.
so I'm going to divide both sides by 10, right?
Yes.
And you should have gotten 7, not 10. Okay.
Well, sorry, seven. I
Okay.
don't see it for.
And you
I just went.
and you've gotten it to the final level. Okay, no problem. That's a good one. So, but that means you should always be careful when you're solving anything to cross check over your work. Okay.
I wasn't, I, I wasn't even looking at it from well.
No problem. Mistakes do happen. You understand me?
Yes, sir.
As I was looking at your steps, I saw that the whole thing was okay. But when I saw 10, I was like, okay, let's break it together. So I'll give you another one to try. Okay.
Yes, sir.
Okay. So right now we have another question we want to look at. This is question 3. This says if 6r 7 base 8 equals to 511 base 9, find r. So what we have to do is to convert everything to base 10. So this is going to be 6 times 8 raised to power 2 plus r times 8 raised to power 1 plus 7 times 8 raised to power 0 equal to 5 times 9 raised to power 2 plus 1 times 9 raised to power 1, then plus the last one there times 9 raised to power 0. So all of the digits here, you can see uh, these digits 6, r, and 7. This is 6, this is r, and this is 7. So we multiplied all of them by the base, and this is 511. You can see this is 5, this is 1, and this is 1. Multiply them by the base and raise them to those powers based on the number of remaining digits. Okay, so its square is going to be 64. That is 8 times 8, that's 64. So we say 64 multiplied by 6. That's 64 times 6 is going to give me 384. So 384. Then 8 raised to power 1 is 8. So 8 times r is 8r. Then 8 raised to power 0 is 1. 1 times 7 is 9. So I have the other side. 9 squared is 81. That's 9 times 9. So I have 81 times 5. 81 times 5 gives us 405. So the other side, 9 plus 1, 9 raised to power 1 is 9 times 1, so that's 9. Then 9 raised to power 0 is 1, 1 times 1, that's 1. So on the left side, I have 384 plus 7, that is 391, plus 8r. Then on the right side, I have 9 plus 1 is 10, plus 405, that's 415. So 8R, we collect like times. This doesn't have any R, so it comes to be the number that doesn't have any R too. So we have 8R equals to 415 minus 391. So when we say 415 minus 391, we got 24. So 8R equal to 24. Then we divide both side by 8. Divide by 8. We have R equal to 24 by 8, which is 3. So R is going to be 3. That means what we're saying is that 638 637 base 8. And why did I write that? So 637 base 8 equal to 511 base 9. That is a story for another day to check if it's correct or not. If it's equal or not. Thank you. So, right now, we have another question to look at this time around. This is subtraction with 4. Should that be number 3? See, this is number 3. So, number 4. I want to subtract this 16418 base 9 from 18630 base 9. I'm going to quickly explain something. If you have um, 3, 8, 1 minus 1, 9, 2 in base 10, normal subtraction. 1 minus 2 is not possible, but because we're in base 10, if you borrow 1, you have borrowed 10. So if you borrow 1 from here, it remains 7. Then the 1 you have borrowed is a 10 because it's a base 10. So you add a 10 to this 1, it becomes 11. So 11 minus 2 gives us 9. So 7 minus 9 is not possible again. If you borrow another 1 from this place, it becomes 2. Then the 1 is a 10. If you add it to 7, it becomes 17. So we can say 17 minus 9, that's going to give us 8. So we write 8 here. Then 2 minus 1 is 1. So the answer is 189 base 10. So that we can say 381 minus 192 gives us 189. So the same thing we're going to do in base 9. Let's do this question that's in base 9. We have 18630 at the top, then minus 16418 at the bottom, base 9. 0 minus 8 is not possible to borrow 1. So when you borrow 1 from here, this becomes 2. The 1 is a 9, plus 0, that's 9. 9 minus 8 is 1. Then 2 minus 1 gives us 1. 6 minus 4 gives us 2. 8 minus 6 gives us 2. 1 minus 1 is a 0. We don't need that. And that is the answer. The answer is 2211 base 9. We're going to continue shortly together. Now, looking at this one, I want to re-explain this so that we have done this first one, but let us assume we have not even done it. We want to explain from normal base 10. So I have 1 minus 6 is not possible, but because I'm in base 10, if I borrow 1, it's 10 I borrow that I'm going to add to this one to give me 11. And why is this so? It's because you must count 10 values here before you jump to the next place value. Like tens of these units gives us one of these tens places, and 10 of the 10 places gives us one of the 100 places. Is that clear?
Yes, sir.
Just like if you say 10 naira gives us $1, and that means if I borrow $1 from here and take it back to this place in another currency, it becomes 10 of it. So now I have 11 minus 6 give me 5. Then 1 that remains here minus 8 is not possible. So I borrow another 1 becomes 4, and it's now 10 again plus the 1 to make 11. 11 minus 8 is 3, and 4 minus 1 is 3. Now, to the one that I did in base 4, 2 minus 3 is not possible. But because we're in base 4, so the currency is in 4 folds, I borrow this 1, it becomes 0. So when it comes here, it becomes 4. 4 plus the 2 that was there give me 6. So 6 minus 3 gives me 3. Then 0 minus 2 is not possible. I borrow 1 again. This 1 becomes 2. Then it changes to 4 when it gets here. Minus 2 gives me 2. Then 2 minus 1 gives me 1. So we can translate that to this one that we did. That 0 minus 8 is not possible, but because we're in base 9, we borrow 1 from 3, it gives us 2, and it comes here to become a 9 because of the base. So 9 minus 8 gives us 1, then 2 minus 1 gives us 1, 6 minus 4 gives us 2, 8 minus 6 gives us 2, then 1 minus 1 gives us 0. So the answer is 8. Is that clear to you?
Yes, sir.
Now, the other part that I said I want to explain is the addition part. You will see that if I had 335, which was the previous answer here, if I add it to 186, it's supposed to give me 521. Let's see. So 186. Now, it's in base 10. 6 plus 5 is 11. We cannot write 11 because we're in base 10, okay?
Okay.
Yeah. So we're going to say how many of the tens, how many of the next currency can we see in this previous one? That is 1 of 10, then remainder 1. So it's our remainder that's our answer. Is that clear?
Yes, sir.
So I keep that one. I keep it on top of the next place value. So 8 plus 3 is 11 plus 1 that gives me 12. I cannot write 12 here again because I can see another currency there or another place value there. Okay. So with that, I would say in 12, how many 10? That's 1. Remainder 2. Again, the remainder has been our answer. So I'll keep that one on top here. So 3 plus 1, that's 4, plus 1, that's 5. Because it's less than the place value, I have no issue. Normally, if I am adding a number like 211 plus 322 in base 10, I have no issues with 1 plus 2 giving me 3, and giving me 5 because they are less than the base. Is that clear?
Yes, sir.
But whenever they are equal or greater than the base, and there is still another place value, then I must check how many times the place value can go in it. I mean, the base can go in it. So, the same way, I'm going to try to do 1, 2, 3 base 4 plus 1, 2, 3 base 4 to see whether it will give us this 3, 1, 2. Is that clear?
Yes,
So,
sir.
1, 2, 3 plus 1, 2, 3 in base 4. 3 plus 3 is 6. Is greater than the currency of the base. So, how many 4 can I see in 6? That's 1, remainder 2. Now, 2 plus 2 is 4. Plus the 1 here, that's 5. Is greater than the base. So how many 4? 1, remainder 1. Then 1 plus 1 is 2. Plus the 1 I kept here, that's what? 3 in base 4. Okay?
Yes, sir.
The same way, 2211 plus this one should give us the one at the top. Let's check it. So let's say 16418 plus 2211. 2211 in base 9. 8 plus 1 is 9. Since it's equal to 9, I can't write 9. I can't write that base, okay? So how many 9 is 9? That's 1,
Yes,
remainder
sir.
0. Then I keep the 1 on top of this one. 1 plus 1 plus 1, that's 3. Then 4 plus 6, 4 plus 2, that's 6. Is less than the base. 6 plus 2, that's 8, is less than the base. And I drop a 1 down. So it gave us the number at the top. Is that clear?
Yes, sir.
So I don't know if you want to jot anything down on this page before I give you the next one, right?
I know I'm right down.
Okay, write it down. So when you're free, let me know. So we have another question on this number base. 202, 212 base 3 minus 121 base 3 plus 222 base 3. Let's follow BODMAS. BODMAS says addition before subtraction. So we can say 212 base 3 plus 222 base 3 minus 121 base 3. So let's do this addition first. So 212 and 222 base 3. 2 plus 2 is 4. Because it's greater than the base, how many 3 in 4? That's 1, remainder 1. Then 1 plus 2 is 3 plus 1, that is 4. Again, 1, remainder 1. Then 2 plus 2 is 4 plus 1 is 5. So how many 3? That's 1, remainder 2. Then I bring down the final 1. That means this is 1, 2, 1, 1. Then I can subtract this one from. So I'll say 1, 2, 1, 1 minus 1, 2, 1 base 3. So 1 minus 1 is 0. But 1 minus 2 is impossible. So I have to borrow 1 from the neighbor, which is remaining 1 here, and it's a 3 I borrow, plus 1, that's 4. So 4 minus 2, that is 2. Then I have 1 minus 1, that is 0. Then I drop down the final 1 since there is nothing to take away from it. So this is 1020 base 3. That means the answer to this is 1020 base 3. We're going to continue shortly.
Yes,
So,
sir.
yeah, let's look at this question 6. It says simplify 1 base 2 raised power 2. What this simply means is that 1 base 2 times 1 base 2, okay? So you're going to say 1
Yes, sir.
times 1. Then 1 times 1 gives us 1, the other 1 times 1 gives us 1, then this second 1 times 1 gives us 1, and this times 1 gives us 1. So we will not forget that we're in base 2. So this 1 drops down as 1, while this 1 plus 1 gives us 2, but we cannot write 2 because we're in base 2, okay? So how many 2 is in that 2? That's 1,
Okay.
remainder 0. Then this one is plus nothing, which is 1, but we have a 1 here that if we had it, it will give us 2. So how many 2 is in 2 again? That's 1. Okay, wait a minute. I think something has erased there. Let me try that again now. So the first one drops down as 1. Can you see it?
Yes, sir.
Then 1 plus 1 gives us 2. We cannot write 2. Okay. So how many 2 is in 2? That's 1, remainder 0. Then the last one is plus nothing, which when we add to this one, it becomes 2. So again, we cannot write 2. So how many 2 is in that 2? That's 1. Remainder 0. Then you bring down the final 1. Is this clear to you?
Yes, sir.
So I'm going to write it down now, write the question and the solution, so that I'll give you the one you will try. So we'll look at this question together based on the work you submitted. Like I explained to you, I said you will multiply it 3 times, but it's always advisable. We want to say 101 base 2 times 101 base 2 times 101 base 2. You can use your video now, but that is the meaning of power 3. So it's always advisable to go by this multiplication first. Then whatever you get, you multiply with the third at the third level. Can you hear me?
Yes, sir.
I mean, your video is off. That's why I'm asking whether you're there. So 101 times 101. So I get this one. This one will be 1 times everything at the top. That's 101. And 0 times everything at the top. That is 000. Um, Again, 1 times everything. That's 101. So I firstly get this. Nothing is here. So 1 down. Nothing is here. 0. Then 1 plus 1 is 2, but because we're in base 2, we cannot write that 2. So how many 2? That's 1, remainder 0. And 0 plus 0 is 0, plus the 1 here, that's 1. Then I bring down this one. So this is just the 2 times multiplication there. Now the third one. Are you getting this?
Yes, sir.
Good. These ones are not there because I mean that they don't contain anything. So now I have 0, 1, then multiplied by 101. Okay,
Yes, sir.
good. So let's do that one times 101. So 1 times everything gives us 10011. 0 times everything gives us 00000. And 1 times everything again gives us 10011. So we add this layer together. Nothing is here, so we get 1. Nothing is here, we get 0. We get 1 here, we get 1 here, we get 1 here, 1 here, and 1 here. So finally, we have this in base 2 rather than base 3. So that means we're saying that 101 base 2 raised to power 3 gives us 1, 1, 1, 1, 1. How many? 1, 2, 3, 4, 5. 0, 1 is 2. Is that clear to you?
Yes, sir.
Okay. Let me give you some time to write it down.